Floretta's points per basketball game are normally distributed with a standard deviation of 4 points. Floretta's scores, actually before we even move on, normally distributed means that if you made a histogram, it should look like a bell-shaped curve. That's the normal distribution. So we get to do something with the normal distribution. We can start using a z-score table, and therefore we can start using the z-score formula. This is the z-score formula, where this is the Greek letter mu, this is the mean, and this is the standard deviation. I'm just I don't want to write it all out by hand there. Standard deviation is that funny little Greek symbol with the tail on the end. Okay? So that's the z-score formula. We're going to use that quite a bit this week. Let's see. They tell us the standard deviation is 4, so let's start plugging things into the formula. 4 goes down here for standard deviation. Flores scores 10 points. This value, this number here is like the value you're trying to convert to a z-score, or like it's the number you're trying to test. You want to find a probability about. So this is often a number that we plug something in for. So we're going to hold on to that. It's going to be 10, but I'll explain why in just a second. The z-score is -4, so we're going to plug in -4 into the z part of the formula. And they're asking us, what's the mean points per game, this mu? So they're asking for the mean. That means that's the thing we don't know. 10 goes in here because 10 is the value for the z-score that we have. So in other words, like, you can really whittle down x and figure out what it's supposed to be once you've figured out what the mean is, the standard deviation, and the z-score. It's the number that's got to be left over. But to try to get the mean by itself, to help with the algebra part, we need to get rid of the 4 on the bottom. So we're going to multiply both sides by 4. So 4 times -4 makes -16. 4 times something over 4 cancels out. So we got -16 equals 10 minus mu. Still trying to get 10 by itself. So we got negative, this isn't going to make any sense, I don't think. Oh yeah, it will. -16 equals 10 subtracting my mu. Just copying up here so I have more room to work. Trying to get m by itself, so subtract 10 from both sides. So we get -26 equals negative mu. Negative sign still there. And then to get rid of a negative sign, you could divide both sides by -1. So mu is 26. So it's really about plugging in the numbers into that z-score formula and then solving. So let me try to get another one here. Skip over this one. I'll make another video for this topic. This one looks similar. Yeah, I think this is the one that we did from the same topic. Annie was told that her math test score was a 3, so that's going to go in for x in the z-score formula. Okay, because that's not the mean, it's not the standard deviation, it's not a z-score, so that means our x is 3. Oh, sorry, hold on. This is 3 standard deviations below the mean. That's a little different. We'll come back to that in just a second. If a test score were approximately normal with a mean of 99, so that means we're going to plug 99 in for mu, and the standard deviation is 4, so that means we plug in a 4 in for the standard deviation. What was Annie's score? That's where we're going to use this part here about the 3 standard deviations below the mean. Okay, a z-score is actually just a representation of how many standard deviations away from the mean we are. Okay, so like let's say there's a distribution that had a mean of 10, a standard deviation of 5. Well, what's one number that's 1 standard deviation away from the mean? Right, 15 is 1 standard deviation away. Or maybe 5 is 1 standard deviation away. That's 1 standard deviation below the mean. 15 is 1 standard deviation above the mean. That's what you would get if you plugged it into the z-score too. If you plug in 15 into the z-score formula, you get 1, which is what we said. It's 1 standard deviation away. So when they say that Annie's math test score is 3 standard deviations below the mean, that means it's a -3. Because negative z-scores, let me erase this, negative z-scores represent values that are below the mean. They're below average values. Okay, so if you see something that's 3 standard deviations above the mean, that means z equals 3. And then we got a little equation we can solve for x. Okay. So we've got to multiply both sides by 4. That gets rid of the 4 on the right side. And then we got to add 99 to both sides. So in case you need help with the negative and positive numbers, that's like saying 99 subtracted by 12 makes 87. Okay, don't be afraid to let me know if you still have questions on this topic though.